this lecture we are still covering the adrenal cortex, so we're still looking at the true endocrine part of the adrenal gland, but we are moving away from the zona fasciculata, or the middle layer, which secretes the glucocorticoids that we looked at in the first two parts of the lecture. And we now move on to the zona glomerulosa, or the outermost layer of the adrenal cortex. So this outer layer, or the zona glomerulosa, secretes mineralocorticoids. So mineralocorticoids are named for their ability to regulate the electrolyte concentrations of the extracellular fluids, and the most important mineralocorticoid produced by the adrenal cortex is aldosterone. So that is the hormone that we will be looking at. So the function of aldosterone is it maintains the sodium balance of the body by reducing the excretion of sodium. So how does a hormone, or how does anything inhibit or reduce the excretion of something? Obviously it needs to target the kidneys, because the kidneys control excretion. So the target of aldosterone are the kidney tubules. And basically, maintaining the sodium-water balance, what aldosterone does is it increases the reabsorption, or it stimulates increased reabsorption of sodium by the kidney tubules. So in the kidney tubule, sodium is then reabsorbed back into the blood. So it's prohibited from being excreted. But the specific target for aldosterone to increase the reabsorption of sodium is the sodium-potassium ATPase pump. So because the sodium-potassium ATPase pump is the actual specific target, simultaneously what aldosterone does is it also increases the potassium excretion at the level of the renal tubules. So that's how the water, or the sodium-water balance, or electrolyte balance, is maintained. So increased aldosterone equals increased sodium in the blood, but at the same time it equals increased potassium excretion, so there's decreased potassium in the blood. Okay, so obviously since aldosterone is involved in maintaining the sodium-water balance, it is also indirectly involved in the regulation of blood volume and blood pressure. And it's involved in this regulation by playing a part in the renin-angiotensin-aldosterone system, or the RAS system. And in this system, aldosterone is released in response to increased angiotensin II, which we'll take a look at a little bit later. So if we look at some of the primary stimuli that cause the secretion of aldosterone, basically the stimulus would be changes in potassium levels, and changes in sodium levels, and changes in blood volume or blood pressure. So specifically, because aldosterone aims to decrease potassium, the stimulus for release would be increased blood levels of potassium. Similarly, if there are low blood levels of sodium, aldosterone would be secreted, because remember the goal of aldosterone is to increase the blood levels of sodium. And then also if there are decreased blood volume or blood pressure, or if there is decreased blood volume and blood pressure, aldosterone will be released in the aim of increasing blood volume and blood pressure by means of the RAS system. So this is just a recap to how decreased blood pressure and blood volume causes the release of aldosterone. So I'm not going to go through this in too much detail, because I presume that you've covered this in your renal lectures. So basically, decreased blood volume or blood pressure is a stimulus which causes the kidneys to produce the enzyme renin. What renin then does is it converts the inactive angiotensinogen into angiotensin 1. Angiotensin 1 is then converted by the ACE enzyme, or angiotensin converting enzyme, into angiotensin 2. And angiotensin 2 has various effects throughout the body which all aim in increasing blood volume and blood pressure, but specifically the one that we're looking at now is the influence of the adrenal cortex, whereby it stimulates the adrenal cortex to release aldosterone. Aldosterone, as we said, then increases the sodium reabsorption, and this sodium reabsorption will then cause increased volume and maintained osmolarity, which then contributes to increasing the blood pressure. So this is just a recap of the RAS system. So basically, if we just summarize what we've said, aldosterone has primary regulators, and the primary regulators are the renin-angiotensin mechanism, whereby the kidneys secrete renin. This causes the release of angiotensin 2, and angiotensin 2 then causes the release of aldosterone. But then besides for the renin-angiotensin mechanism, there's also the changes in the plasma concentrations of sodium and potassium, as we've said. So those have direct influences on the glomerulosa cells to then cause an increase in aldosterone release. So these are the primary regulators for aldosterone secretion. But we also do have other factors which also influence the release of aldosterone. So firstly, stress causes the activation of the HPA axis, which we already know because we've said that stress is also one of the main stimuli that causes the release of cortisol, and cortisol is of course released also through the HPA axis. So stress activates the HPA axis, or the hypothalamic pituitary adrenal axis, and we know when this axis is activated, ACTH is released. So adrenocorticotropic hormone is released from the pituitary. And ACTH stimulates the adrenal cortex, and with the stimulation of the adrenal cortex, it could cause increased release of aldosterone. So basically, one more factor that causes the secretion of aldosterone is stress by means of the activation of the HPA axis. Then another factor which influences aldosterone secretion is atrial natriuretic peptide, ANP. Now this is released from the heart, but this is not a promoting factor. ANP is actually an inhibiting factor. So in times of increased blood pressure or blood volume, the heart releases atrial natriuretic peptide, and ANP then targets the activity of the zona glomerulosa cells within the adrenal cortex, and it decreases their activity. By decreasing the activity of these cells, it means that these cells will decrease their secretion and release of aldosterone, and with a decreased release of aldosterone, it then means that blood pressure can be restored and decreased in response to the increased stimulus. So this is an inhibitory factor that influences the release. So in summary, this is what we've looked at. We've looked at the primary regulators. So the primary regulators, as we've said, includes decreased blood volume or blood pressure by means of the activation of the renin-angiotensin aldosterone system, which then directly causes the release of aldosterone. But then also another primary regulator is the change in potassium, but also something that's not added obviously in this diagram is the change in sodium. So a decrease in the sodium concentration in the plasma or an increase in the potassium concentration in the blood also acts as direct stimuli for the release of aldosterone from the zona glomerulosa cells. But then on this side of the diagram is also included the two other factors that we spoke of. So stress activates the hypothalamus to secrete corticotropin releasing hormone. Corticotropin releasing hormone from the anterior pituitary causes the release of ACTH. ACTH causes the stimulation of the adrenal cortex and thereby also increases the release of aldosterone to a certain extent. And here we have our inhibiting factor. So opposite to the initial stimulus over here, when blood pressure is increased or blood volume is increased, the heart produces atrial natriuretic peptide or ANP, and this then inhibits the activity of the zona glomerulosa cells so that aldosterone is not secreted, and thereby aiming to decrease blood volume and blood pressure.